Hi guys, welcome back. In the last session, we are trying to understand what is stateful container and stateless container. By default, Docker containers are stateless containers. When we stop the container, when we remove that container, whatever the data that is generated by the container, we are losing. So here we are running our application in the Docker. So here we are having two images. One is application image, another is a Docker image, database image. Application image that we have created and a database image is available in the Docker Hub. Now, MySQL database we are running in one container. Spring Boot application we are running in one container. People will access our Spring Boot application and they will insert some data. That data is inserting in the database table. When I stop the container, when I remove this database container, whatever the data I have stored in the database, I'm losing that data. So that means this container is stateless container. But what my requirement is, even if I delete the container, I should not lose my data. When I create the new database container, I should get the old data as well. That is what we do in the real time. So stateless container and stateful container. Data will be deleted after container got deleted if it is a stateless container. Data will be maintained permanently if it is a stateful container. Docker containers are stateless containers by default. In the above boot application, we have used MySQL database and all that stuff. Let me show you the demo once again. So here guys, I'm having my application image and database image. Docker Compose YML is also available. Let me go for Docker Compose PS. Now containers are exit. Containers are exit. Okay. If I go for Docker Compose down, it removed all the containers which are available. It removed all the containers which are available. Now let me execute Docker Compose up-d. Sorry. Docker Compose up-d command I'm using to run my containers and run the containers in the detached mode. It is creating database container and it is creating application container and network also created. Now here, once these containers are started, we can check the status of that Docker Compose PS. Now containers are started. DB container started on the 3306 port number. Application container started on 8080 port number. So now we have already enabled 8080 port number in the security group of our machine. So inbound rule that 8080 protocol is enabled to allow the traffic. Now go to our EC2 instance, check the public IP, access its public IP, go here and colon 8080. So when I access it, my application is loaded. So this is user interface of the application. I want to insert one record into the table, DevOps and book price, something like 2000. Click on submit. Record is inserted. Now go for AWS and I want to insert this record. Click on submit. Two records are inserted into my application database. As a user, I'm accessing the front end of the project. So here end user is available. End user is accessing front end of our application. That front end communicating with the back end and inserting the database, inserting the record into the database table. Now fine, my application is up and running. People are able to access my application. They are able to insert the record also into my application. Now, for example, I have some problem with my containers. I want to stop them and I want to recreate them. So let me go for Docker Compose down. If you stop, then you can get the data back. But here I am down. I'm using down. That means my container will be deleted. My container will be deleted. Suppose, for example, if I go for a Docker Compose stop, it is just stopping the container. It is just stopping the container. Docker Compose stop command will just stop your container. Next one, again, you can go for Docker Compose start. So here Docker compose stop command is used to stop the containers which are running. Docker compose start command is used to start the containers which are stopped. Now when I execute Docker compose start, again MySQL DB started and application started. So once I stop and start the container, let us see what is the behavior of the application. If I stop and start my application, 1 minute, it is getting restarted, guys. Containers are stopped. So when I stop and start the containers, am I losing my data or am not losing my data? Guys, you see, I have stopped my containers and I have started them again. When I stop and start the containers, am I losing the data which is available in the database, or I'm not losing the data available in the database? I'm not losing the data available in the database table. Data is maintained because container just stopped and it is restarted. So how I have stopped containers and how I have started the containers? By using Docker compose stop command, I'm stopping my containers. By using Docker compose start command, I'm starting my containers. When I stop and start, I'm not losing the data. Data is available as expected. Now let's go for Docker compose down command. Stop is different, down is different. Stop means just to stop the containers. We can restart them by using start command. Docker compose down. Docker compose down means not only stopping the containers, even it is removing the containers from the machine. Are you guys able to understand the difference between Docker compose stop and Docker compose down? Stop means just to stop the containers. Down means stop the containers and remove the containers. Okay, I have removed my containers. Now my application is not accessible because containers are deleted. Containers are not available. Now let me restart the containers by using a command Docker compose up -d. Docker compose up -d. Now I am recreating my containers. Network is created and Docker compose is also created. Docker network is created and Docker compose is also created. Now let's verify the status of the application. Containers are removed and containers are recreated. When the container is recreated, am I getting the data or I'm not getting the data? When my container is recreated, am I getting the data back or I'm not getting the data back? I lost the data. I lost the data. Are you guys able to understand the difference between Docker compose stop and Docker compose down? When we are losing the data, when we are using Docker compose down, our database container is deleted and we have recreated the database container. As the database container is recreated, we lost the data available in the database. So our application lost the data. Now in this scenario, what I want to do is, even if the database container is recreated, I don't want to lose the data. I don't want to lose the data. I want to maintain the data. These are my containers. These are my containers. Now see here, in my host machine, Docker containers are available. In my host machine, Docker containers are available. Now, what I want to do is, my database is having the table to store the data. So whenever user access front end of the application, the data is coming and the data is storing into database table. This is my host machine. Right, guys? In this host machine, our Docker containers are running. Okay, let me consider this as host machine. Inside this host machine, the Docker containers are running. Okay, this is my Docker host machine. That means in which machine the Docker is running, that is called Docker host machine. So this is our container 1 and this is our container 2. Two containers are created. One is application container and another one is the database container. Now what I want to do is, I want to create one volume. I want to create one volume on the host machine because containers we are deleting. If you stop the container and if you start it, you will not lose the data. But here I'm deleting the container. When I delete my container, I'm losing the data. So that's why what I will do is I will go for a value mounting. On the host machine, I will create one directory with a name called app. You can give any name for that. I'm creating one directory on the host machine with a name called app. And here, whatever the database container is available, the database container will be mounted to app volume, something like this. Okay, guys. So this is my volume that I'm using. This is the volume that I'm using. So whenever my database container is started, my database container will be mounted to one directory on the host machine bind mount value. Okay, guys. Now here, earlier in the current Docker file, we have given the value. In the current Docker file, we have given the value, but that is an anonymous value. So here we have given var lib MySQL. So volume is available. If you stop and start, you will get the data from this value. But if you delete the container, that volume also will be deleted. So that's why I want to make it as a stateful container. In the host machine, I'm creating one directory with a name called app directory. My volume will be pointed to this app directory. Now I will create the containers again. When I create the container, this MySQL database container will point to this volume available on the host machine. And whatever the data you store in the database, that the data will be synced to the volume on the host machine. So now if you delete the database container, if you recreate the container, that new container, whatever is creating, that also will be pointed to the volume. So whatever the data available in the volume, container will use it. Whatever the data is available in the container, volume directory can use it. Like this, we can make our Docker containers are stateful containers. So now here, observe. When I delete my container, the volume, whatever the anonymous volume I have given, that volume is also deleted. Now, even if the container is deleted, I should not lose the data. If one database container is deleted, if you recreate the database, if you create the new database container, old data should come to the new container. How old data will come to the new container? That's where we are mapping our container to host machine value. We are mapping our container to one directory on the host machine. So whatever the data that is inserted to the MySQL database container, that data will be mounted to this volume directory on the host machine. When you delete the container and if you recreate the container, that container will fetch the existing data available in the host machine directory. Now let us see how to make that change here. In my host machine, I will create one directory called app directory, and that app directory I will specify here. That app directory I'm going to specify here. So here this is the app directory that I have specified as a volume on the host machine. So now here, let me give that volume name / here dot insert mode dot / app. Right. So like this, I'm giving the volume app directory that is pointed to app directory. So earlier I have just given the anonymous volume without name. Now this volume I'm mapping to app directory. So where is this app directory? This app directory I have given on my host machine. So if you see in the host machine, we are having app directory. I have created one app directory. You can give any name for this. And this app directory name I have configured for the value. Okay, guys. Now ls-l vi docker compose.yml. Whatever the app directory is created on the host machine, that app directory I am pointing to the MySQL database path. So var lib MySQL, this is the location in the container where the data will be stored. So whatever the data is storing in the MySQL, that should be pointed to app directory. If you delete the MySQL database, no problem. It is pointed to app directory. When you recreate the new database container, it will fetch the data from the app directory. So that means the data sync will happen between database container and our volume. Now I have configured that value with the app directory, save it. Now let's go for Docker Compose PS. So currently the containers are in the stopped state. Let me delete them and recreate. Docker Compose down. It is used to stop and delete. My containers are stopped and my containers are deleted. Now let me go for Docker Compose up-d. Now I am creating my containers. My containers are created. Let us go here and see. No data will be available because first time we have created the containers. Refresh. Containers are getting started. Once the containers are started, we should be able to access our application. So now our containers are started. 1 minute. So already we have mounted to app directory. Previously, whatever the data I have in the app directory, that data I got. Let me insert another record. Go for Spring Boot. Author name, something like Rod Johnson. Book price, I'm giving some 250. Submit. Boot is inserted. Then let me go for Angular. Author name, something like this. And book price, some 750. Click on Submit. So there are 4 records available in my application, guys. Now let me go and execute Docker Compose down. What is the meaning of down? I'm not using stop. Stop means just to stop the container, restart the container. Here I'm using Docker Compose down command. When I use the Docker Compose down command, what happened? It has stopped that container and it has removed the container and removed the network also. Docker Compose down. When I use Docker Compose down and when I refresh my application, you check it, application is not accessible because containers are deleted from the host machine. Now, let me recreate the containers. Docker Compose up-d. Docker Compose up-d. I have recreated my containers. When I recreate my containers, you check the application, the data is coming back or not. Application is not started yet. Yes. Now see, I have executed Docker Compose down command. Then my containers are stopped and my containers are removed from the machine. Then again, I have used Docker Compose up. The containers are recreated. When the containers are recreated, did I lose the data or I am getting my 4 records back? Am I losing the data? Am I losing the data or I'm getting the data back? I'm getting the data back. So now, can I call this as stateful container now? Can I say my database is a stateful container now? Yes, my container is a stateful container. So first I have started the container. I have inserted some data into my application database through the user interface. Then I have deleted the container by using Docker Compose down command. I deleted the container by using Docker Compose down command. Then again, I have recreated the container. When I recreated the containers, I am getting my old data back. Now tell me how the database container is getting the data back. Container data is mapped to one value. So when the container is deleted, no problem. Data is already mapped to value. When the new container is created, the new container will pick up the data from the value. So like this, we need to make our containers as stateful containers if you don't want to lose the data. Okay, guys. After changing the Docker Compose YML, we no need to rebuild the project, guys, because we are changing the only value, not the image. When you make the changes to Docker Compose YML, so see here, when I make the changes to Docker Compose YML, I'm not building the image. I'm just stopping the containers and I am starting the containers. That's it. When we make the changes to the Docker Compose YML, you no need to rebuild the project. You just need to stop the container and create the container. So you see here how I have specified that value mapping. I specified that value mapping on the host machine. I have created one app directory. That app directory I pointed to var lib MySQL. What is this varlib MySQL? Yesterday also I have given the varlib MySQL. It is an anonymous value. So when the container is available, the data will be available in this location. When the container is deleted, the data will be deleted from this location. So that's why I mapped this volume, this container database location to app directory on the host machine. This is called bind mount. That means container data we are mapping to host machine. Container data we are mapping to host machine, so that even if the container is deleted, we will not lose our data. So by using this mapping, one container is created, that container data is mapped to app directory. After some time, I have deleted my container, no problem. This data is already mapped to bind mount, right? Whenever you recreate the container with the same configuration, so this whatever the data available in the app, it will go to this location. So initially, whatever the data is inserted in the database in this location will come to app. When you delete the container and when you recreate the container, whatever the data is available in the app directory, it will come to this location. So the old container data is coming to the new container from this value. Old container data coming to new container with the value. Are you guys clear? People are asking, sir, can we use same volume location for two containers? So if you use same volume location for two containers, no problem. That will map the data. Yes, two containers also can map to the same location, no issue. But generally we don't do that. Got it? So with this we understood what is stateless container and what is stateful container and how we are mapping. So this concept is called as bind mount. Bind mount. Okay, so this volume name you can give anything. Whatever the name you give for the directory on the host machine, that name we are going to configure in the Docker Compose YML. Okay, guys. So now here, let me update my Docker Compose YML. So making Docker container stateful, making Docker container stateful using bind mount. Making Docker container stateful using bind mount. All right. Create a directory on host machine. So you can create a directory on the host machine by using mkdir, something like this. Configure app directory to container. Configure app, mount app directory to container. Map app directory to container in Docker compose.yml file. Okay, guys. So once it is done, then start Docker Compose service. Start the Docker Compose service using Docker Compose up, using Docker Compose up -d. So it is in the detached mode. Docker Compose up -d. Okay. Access the application and insert the data. Access the application and insert the data. Stop, delete Docker Compose service. Delete Docker Compose service using below command. Right. What is the command? Docker Compose down. After this, again start. After deleting the containers, again start Docker Compose service and access application and see data. It should be available. So that is what the process that we have done. How we are making Docker containers stateful by using bind mount. So I'm creating one directory on the host machine. You can give any name for the directory. I'm using the name as app. Map app directory to container in Docker compose YML file like below. Okay. Now here I'm doing that mapping. Once we have done that mapping, then Docker compose up-d. With this, my containers will be created. Once the containers are created, then access the application and insert the data in that. Once it is done, then delete Docker compose service using below command. So what is that? Docker compose down command. Once you use Docker compose down command, then again start the Docker container. Okay. Once you again start the Docker compose service and access application and see the data, again start the Docker compose service. So how we are going to start it again? Same command, Docker compose up-d, access the application and check the data. Previously inserted data also should be displayed in the application like this. So if you are able, after deleting and recreating the container, if you are able to see the data, that means your Docker container is stateful container. That means your Docker container is stateful container. Are you guys able to understand? Are you guys able to understand? So this is one approach that we are going to use to work with the database containers. But in the reality, guys, but in the real time, databases also will be maintained in the cloud platform, AWS cloud, because unlimited data that we can store in the database. If you go for AWS cloud, there is a service called RDS service. Most of the projects are going to use RDS, managed relational database service in the AWS. So here, if you create the database by using a Docker, that means you are creating the database. You need to manage the database. You need to manage backup of the database. You need to manage the security of that. So you need to take care of everything related to your database. By mistake, if you lose the data, then it will become a lot of problem. So that's why in the real time, people will not maintain the databases in those machines. People will go for cloud databases. In the AWS, there is a database called RDS database, RDS service. By using that RDS service, we can create the cloud database. In the AWS classes, we will understand what is Amazon RDS and how to create the database by using Amazon RDS. Are you clear? Do you think that people will maintain the databases by using these Docker containers? Do you think that people will maintain the databases with the Docker containers in the real time? Very rare, because if you create the database by using a Docker container, there is a chance of losing the data. If your container is deleted by mistake, then we will lose the data. Customers will not accept if we say that we lost our data. So that's why in the real-time projects, companies will go for cloud databases. So, but how to set up the database by using Docker Compose and how to make it as a stateful, we are able to understand. We got the concept, but in the reality, cloud databases will be available. AWS cloud having a service to provide the database, which is called Amazon RDS. Amazon RDS in the AWS in the future. So in the future, AWS classes will start for us. At that time, we will understand what is Amazon RDS and how to create the database by using Amazon RDS. Okay. When we use Amazon RDS in our application properties file, right? Yesterday, I have shown you the whatever the properties file is available for the application to load the data, YML data, right? In this application.yml, instead of MySQL container data, we will configure AWS RDS database so that our application will connect to the AWS cloud database. How application will connect to the cloud database? If any Java developer is available in this class, I have already uploaded one video how Spring Boot application will connect to Amazon RDS. AWS RDS will be available. AWS RDS, if you go to here, I have prepared one video on that. Spring Boot with AWS RDS database. Within 15 minutes, I have explained in that video how a Spring Boot application can connect to AWS RDS database. AWS RDS database, nothing but that is a cloud database. So Docker container, we use it to create the database, but it is a risk, right? If we delete the container, there is a chance of losing the data. In the real time, we should not lose the data at any cost. So that's why people will go for cloud databases. So how to create the cloud database, how to connect to the cloud database will come in the future classes. If any Java developer is there, this video will be useful for you to understand how Spring Boot application can connect with the AWS RDS database. Right. So when we are connecting with AWS RDS database, we need to configure AWS RDS database details in our application.properties file. So application.properties file will be available. See here. This is my application.properties. Earlier we configured our container details. Now we are going to configure AWS RDS database details. Now see here, the database username, database password, database URL. So last time what we configured as database URL, the database container name we have configured. So now where is the database that represents host name? What is the host name of the database? So earlier we configured database host name as this, MySQL DB. This is the name of the container, right? We configured. But when I want to connect with cloud database, now you see JDBC : MySQL : database 1 AP South 1 RDS Amazon AWS.com. That is the host name. That is the location where my database is running. 3306 is the MySQL database port number. Courses is the database name. So like this, in the application.yml, the database properties will be configured. Then my application can connect with the MySQL database, which is running in the AWS cloud platform. RDS is a service to manage relational databases in the AWS cloud. It provides cost-efficient, resizable capacity for an industry-standard relational database. So RDS is the most recommended service to work with the databases in the project. Right. Are you clear? How to make our container as stateful? Even we are mapping this to the value in the host machine. Suppose by mistake, if this directory is deleted, by mistake, if this humans may do the mistakes, right? So by mistake, that directory got deleted. Then, or by default, my Docker machine got crashed. I lost my machine. Then I lost my machine. Then what will happen? This directory will be gone and our data also will be gone. You got it? Perfect. So what is the recommended way to manage databases in the cloud? RDS. Now, people are asking, sir, what is there in that app directory? You can't see anything there. So ls-l app directory is available. CD space app directory, ls-l, nothing will be available. Some hidden files will be available. That's it. Okay, guys, in the app directory, we are not able to see. That is just for bounding purpose. Internally, they will maintain that map. Okay, good. RDS is a paid service, guys. It is not a free service. RDS is a paid service. It's not a free service. RDS is a paid and it's not free. Yes, good. Fine. In the AWS classes, it will be covered. Perfect. Okay, fine, guys. So for the volumes, if you give some name and attach that to the location, that will become a named volume. Without name, if you map the volume, then that is called as anonymous volume. If you create a Docker volume, yesterday I have shown you how to create a Docker volume. Docker volume, create volume name. And here we can give the name of the volume that we have created, my volume, something like this. So if you give the Docker volume, my volume, then path, then this will become a named volume. Anonymous volume means the volume which does not have any name. That is called as anonymous volume. If you create a volume and if you map that volume to this path, then that is called as a named volume. So whenever you delete the container by using Docker compose it down, this volume also will be deleted. So that's why I'm going for the bind mount. When I go for the bind mount, even if you delete the container, the data will be available there. Good. Fine, guys.